Hi, in this video, we will see the basic organization or basic addressing modes using the computer architecture and organization. What is the use of addressing modes? In the instructions, the address can be effectively stored with the help of the addressing modes. It will give the trade-off between this storage as well as the instructions. By using different addressing modes, the content from the memory can be accessed in effective manner. The commonly used addressing modes in machine architecture are: first one is the immediate addressing mode, second one is the direct addressing mode, third one is the indirect addressing mode, then register addressing mode, register indirect addressing mode, displacement addressing mode, and stack addressing mode. These are the commonly used addressing modes. Next. In this addressing mode, this is the pictorial representation how the values are stored in the memory and how it is accessed with the help of different addressing modes. Initially, in the instruction, it contains the operands as well as the operator as well as the operand. The operand is available in the memory, or it may be available in the general purpose register, or it may be directly given by the user. That is described in the addressing mode. First one is the immediate addressing mode. In the immediate addressing mode, the operand is directly given by the user. So no need to access any information or no need to access any data from the memory. Hence, that value is directly available in the instruction itself, and which is directly given by the user itself. If we know the values initially itself, we can directly give the values. No need for any accessing, no need for spending more time in that. That is the direct address, immediate addressing. Next is direct addressing mode. In the direct addressing mode, the address is directly given, and that address plays the CPU sends a message and it will access the information from the given address space. The next one is the indirect addressing modes. In the indirect addressing modes, the address of the address is given in the instructions. So the value given in the instruction is not the address, not the value. This is the address of the address. Hence, we need two-level memory accessing in this indirect addressing mode. The next one is the registers. Registers means general purpose registers. These are available inside the CPU itself. The contents are available in the registers. Then we say this is the register addressing mode. The next is the register indirect addressing mode. In that, first the register is referred. Go to the register, the address location is available inside the register, and that address location is then referred, and from that the content is taken. That is the concept of the register indirect mode. Displacement mode means here the address plus the displacement value is given. That is 4000 of R1. 4000 plus the R1 content will give this displacement. And stack addressing mode, here no need to give this address and all. Instead of that, automatically the values can be fetched from the stack. The stack uses the last in first out. So push and pop operations are required for this stack addressing mode. These are the basic addressing modes. Immediate addressing, operand is directly given, and here no need for any memory references. That is the main advantage of the immediate addressing mode. The direct addressing mode, only one memory access is required. Limited address space is there. We can use this one. And the effective address EA can be calculated. That is, the effective address is equal to the address given in the instruction itself. In the indirect addressing modes, large address space is required, and here more than one memory reference is there. Register addressing is directly taken from the register, no need for memory references. And register indirect, here also we need the register content as well as the memory content. Extra memory references required in the register indirect mode. And displacement, this is very flexible mode, but the complexity is very high because first you should calculate. Extra calculation is needed for finding the displacement address. The stack addressing mode effective address is the top of the stack in default manner. The immediate addressing is the simplest one, and this mode can be used to define and use constants and literals. It can be directly given by the user itself. The leftmost bit of the operand field is a sign bit here. Advantage is no memory addresses. Disadvantage is the size of the number is restricted. Only small amount of The small size values can be integers can be represented in this immediate addressing. Whereas in the direct addressing, direct memory access, only one memory accessing is required here. And in indirect addressing, the effective indirect addressing is given by inside referred by the parentheses. The parentheses are to be interpreted as the content of this one. So, if your address is 5,000 bracket means the content of 5,000 is taken and go there only the value is available. Register addressing, automatically the value can be taken from the immediate registers. The drawback of this one is the address space is very, very limited. Few amount of data can be stored inside the register. Register indirect means here it indirect, automatically it will store inside the parentheses. The go to register, refer one value, that value is the address of the operand. Again go to the location, it gives register reference as well as the memory reference. The displacement address mainly is used for base addressing, index addressing, as well as PC related addressing. We use this displacement address. Here, the address value is added with the indirect value to find the actual value. For example, we are giving this as giving the value. If you are giving the value, the address space 50 of 5,000 means you should take this 50. This is directly given address. Go to the location 5,000. Their own value is available. In the location 5,000, the value available is 25 means you take that value and that value with this value. Finally, you will get 75. That is the address of the operand. To find the address of the operand, before that, you go to the memory location, search the value. We need one memory reference. After that, calculate the value. Again, the calculation is there. It will also take some time because the ALU operation is required. Then you will get value. That value is the address of, not the value. This is the address of the memory. Hence, again, you need the memory reference. So, here multiple memory references and multiple calculations are also required in the displacement addressing. But the advantage of this one is it can utilize large address space. Any kind of address can be given by using this technology. Relative addressing means here the implicitly the values are referred, and that is the stack addressing. No need to give the next address space and all. Next value will be taken from the next to the top of the stack. But it needs so many instructions for executing a small program. The stack is the linear location. Items are appended to the top of the stack. And associated with the stack is a pointer whose value is the address of the top of the stack. It's a form of the implied addressing. These are the various types of addressing modes. Hence, I will say one example for this addressing mode. For example, if it is first one is the immediate addressing mode. Example for this immediate addressing mode is move R1, comma, hash 10. Suppose if you want to store the value 10 in the register R1, you knows the value initially, you will directly use this by using this immediate addressing. This is example for immediate addressing. Direct addressing means same manner. If you want to move the content from the location 4,500. Okay. Consider the value available in 4,500 is equal to 10. Same thing, I am moving the value 10, but now the value 10 is available in the memory location 4,500. In this case, I'll give the direct addressing mode, move R1, comma 4,500. Automatically, the memory reference is 4,500. Go and search the location 4,500. There 10 is available. From that, we take the value. That is the concept of the direct memory addressing. Again, indirect memory addressing, in the indirect memory addressing also, same. The difference is here you this one bracket. Bracket indicates this is the indirect. So in this case, instead of 4,500, give another one value or 4,500, the value 10 is there. No, already I told you. Go and refer 4,500, the value 10 is there. Now, instead of taking the same value, go to the location of 10 and search what is available there. Suppose the value 35 is available in 10, that value is taken. So two level reference. First, go to the location 4,500, take the value, fetch the value. 10 is there. Go to the location 10 and then from here there take the value. Two direct and direct. Two directs. Combinedly gives the indirect addressing. Register addressing means instead of this memory location, directly give move R1, R2. The value is available in the register and that is moved to the R1 register in a single clock cycle, single step. Easily, it can be moved from register R2 to R1. That is what called as the register addressing mode. Register indirect means here you should write R1, R2. Instead of address, you are giving the register, but not the value is available in the register. Instead, go and search R2. In that R2, some value will be there. For example, consider 4,500 is available in R2. Then go to the location 4,500 and fetch the value. That is called as register indirect. Displacement means, already I told you, move R1, 400 of R2. Now, go to the value of R2. We know that in the location R2, 4,500 is there. So, add 400 with 4,500. We get the value 4,900. Now, you go to the memory location 4,900. There one value is available. Take that value. That is the concept of displacement. Then stack addressing means directly the value will be. Suppose you are giving move 50. This is the implicit addressing. Here it can be directly moved to the top of the stack. This is all about the addressing modes. Thank you.